to Unit 4, Extending the Number System. Our three standards cover rational, irrational, and radicals. Rational exponents are exponents that are fractions, and you always have to remember that rational means fractions. So when you have two alike numbers and fractions as exponents, you add the fractions to equal 1. So let's take, for example, 5 to 1/2 and 5 to the 1/2 power. So because 5 and 5 are the same number, obviously, you're going to just add the exponents together. So 1/2 plus 1/2 equals 1. So then you take 5 to the first power, and anything to the first power is 5. So let's try again. We have 12 to the 1/2 power and 12 to the 1/2 power. And we can see that both the numbers and exponents are alike. So add the exponents, 1/2 plus 1/2, which equals 1. Use the 1 and have 12 be raised by the power of 1, so 12 to the first power is 12. So one last time, take 50 to the 1/2 power times 50 to the 1/2 power. Pause and press OK, and press play when done. Okay, so we take the two exponents and add them, which equals 1. Take 50 and raise it to the power of 1, which equals 50. So no matter what, any number raised to the first power will always be itself. Now, when the exponents are any number but 1/2, one way to work it out is separating the fraction. So in this case, we have 4 to 3/2. So you separate the 3 and the 1/2 and have 4 raised to the power of 3, which equals 64. Use the 1/2 or 2 and use it to square root the 64, making it equal to 8. Okay, so we're going to our second standard, which is rewrite expressions involving radicals and rational exponents using the properties of exponents. There are 4 simple rules to know before we start. 1. You're allowed to have exponents that are fractions. 2. The denominator of the number is the square root. 3. The numerator of the fraction is the power. And 4. It doesn't matter which part you work out first. So we're going to head to the chart now, and we're going to be showing properties, the definition, and their examples. We'll be going over products of powers, power of a power, negative exponents, zero exponent, quotient of powers, power of a quotient, radicals as rational exponents, and rational exponents. For our first one, we're going to be doing products of powers. For the definition, we're going to be writing a to the n power times a to the m power, which will then equal a and m plus n. Because because a is the same in the both numbers, it's going to be the same. So, for example, 5 to the 4th power times 5 to the 3rd power will equal 5, and then 4 plus 3, which will then result in 5 to the 7th power. Another example is 6 times 6 to the third power. Because there is no exponent, it's an understood 1. So then we do 6 and 1 plus 3, which will result in 6 to the fourth power. Our next one is power of a power. For our definition, we will have a to the m power to the nth power, which will equal a to m times n. So here we'll have 5 to the third power to the fourth power, which will then equal 5 and 3 times 4. So then result in 5 to the 12th power. Our next one is negative exponents. We will have a to the negative nth power. Whenever you have a negative exponent, you will put it as a fraction, so 1 over 8 to the nth power in order to keep n positive. So for example, we have 5 to the negative fourth power. So we will put a 1 over 5 to the fourth power. Another example would be 4 times 3 to the negative 7th power. 4 will be used as our numerator instead of 1, and then 3 to the negative 7th will stay as the denominator in order to keep 7 positive. Our next one is zero exponent. A to the 0 power will equal 1. So we'll have, as an example, 1 million to the 0th power equal 1. And 2 to the 0th power equal 1. Anything to the 0th power will equal 1. Our next one is quotient of powers. So we will have a to the n power over a to the m power. N and m, we will be subtracting them in order to use it with the a, so a and n minus m. So for our example, we will have 5 to the 7th power over 5 to the 3rd power. We will take 5 and then 7 minus 3, which will result in 5 to the 4th power. For our next one, we will be doing power of a quotient. For the example, we will have a over b to the power of m. So we will have 7 over 5 to the power of 6. So you're going to distribute 6 to 7 and 6 to 5, which will then result in 7 to the 6th power over 5 to the 6th power. Our next one is radicals as rational exponents. So we will have x in the square root and have it be x to 1 over 8. So we'll have a in the square root, and then the denominator will be outside of the root and the numerator on the inside. Because 2 is on the outside, it will be the denominator, and 1 being on the inside being the numerator. So 9 to the half power, which could also be 3. So then our last one is rational exponents. We will have a with m over n, which will then equal n being outside of the square root, a on the inside, and m being the power. That will equal a 1/2, a to 1 over m, and then n on the outside. For example, we will have 8 and 4 over 3, which will then equal 3 on the outside of the square root and 8 to the 4th power, which will then be 8 and 1/3 to the 4th power, which could also equal 8 to the 4th power multiplied by exponent of 1/3. What is the product and why? So for our third standard, we are talking about rational and irrational being added or multiplied and what the result would be. So first we're going to start with the addition rules. Rational plus an irrational will always equal rational. So for example, we have 4 plus 6, which equals 10. 4 is the rational, 6 is irrational, and 10 is irrational. So you can tell all the numbers are rational. Our next rule is rational plus irrational, which would equal irrational. For example, you have 2.3 repeating plus 6, which would be 8.3 repeating, and that would be an irrational answer. Our next is irrational plus irrational, which can equal irrational. And we have 2 square roots. We have the square root of 2 plus the negative square root of 2, which equals 0. Both are irrational, and it's resulting in irrational because adding a negative to the same positive value equals 0, and 0 is a rational number. For example, 2/3 plus 4/5, that equals 1.46 repeating. So both being irrational having resulted irrational as well. Same rules can apply with multiplying rational numbers and irrational numbers. A few examples are square root of 3 over 4 times 4. The square root of 3 or 4 is irrational, so being multiplied by a rational number will result in the answer being the square root of 3, which is irrational because it cannot be simplified. So that's it for extending the number system for the first 3 standards. Head on to Julian and Addison's videos to finish Unit 4 on extending the number system.